Hi friends, let's look at problem 42, trapping rainwater. In this video, we are going to help you understand how to analyze the problem. Actually, the coding part would be rather easy and natural once you digest the analysis. So this problem is marked hard by leetcode. Actually, the logic is rather straightforward. So here, given n non-negative integers representing an elevation map, where the width of each bar is 1. So we want to compute how much water it can trap after rain, right? So here let's mainly look at example 1. So for example, this second one, so this third one, the 0. So the left max is 1 and the right max is actually 3, right? So then the water it can trap actually is the minimum of the left max and the right max minus the height. So here, this is 1, this is 3. So the smaller one is 1. So 1 minus 0 is 1. So you can trap 1 unit water. So here, if you look at this one, so this is 0, right? So this one corresponds to 2 units of water, right? The reason is that the left max is 2, the right max is 3. And then the minimal is 2. 2 minus 0, so this is the 2 units. If you look at this one, this is the height is 1. So the left max is 3 and the right max is 2. So the minimal of 3 and 2 is 2. So 2 minus 1 is 1. This is the 1 unit. So then we just need to linear scan this array and then record the left max and the right max and then do the algebra. So the water trapped is nothing but the left max, the right max, that's the minimal, right, minus the current height or elevation. So we just need to summation over each data points. So this is actually the whole thing. So now let's look at the code. So in between we can do the analysis. So here I'm going to change this height to be capital H, right? So this is just for convenience of typing. So first let's get n. N is the length of this list. And first, if n is less than 2, so we return 0 because nothing can get trapped. So now in order to get the left max and the right max, so I'm going to do something like this. So left, so I'm going to use 0 times n. So the interpretation of left I is the max up to index I inclusive, right? And the right, I'm going to do 0 times n. So the right I would be interpreted as the max, so here up to max onwards from I up to the end. Right. So once you get this, so now you can first record all the left max and the right max up to each index. So here, for the purpose of explanation, so let me give you some detail. First, I initialize left 0 to be the h naught, right? And then I'm going to start from index for I index from 1 to n, right? This means ending before n, right? So then left I would be the max of the previous one, left I minus 1. The reason here we can use I minus 1 is due to the fact that we start from index 1. So I minus 1 actually is greater than or equal to 0, right? Inbound to the left. So now max with respect to the current one. So this for loop will fill up this left list. So similarly, we can do right. So right, we can first fix the last one, n minus 1, h n minus 1. So here I'm writing n minus 1, but you can write, say, negative 1, right? That sounds good. But to be specific, I write n minus 1 here. And then we are going to iterate for I in range. So we start from n minus 2. right? Then ending before -1 with a step -1. In other words, we will go to a-2, a-3, then 3, 2, 1, 0, something like this, right? So the right I would be something like this, the max of right I plus 1. The reason here we can use I plus 1 is because I is less than or equal to n-2. Then adding 1 will be less than or equal to n-1. It's inbound, into the right, actually. So now we'll get this one, right? So here, actually, it's important to notice the interpretation. So here, inclusive, right? Now let's get the result. So the result, let's originally put it to be 0. And then we are going to iterate. So what we are going to iterate, actually the leftmost and the rightmost for sure cannot trap water. So our index will be I in range starting from 1, ending at before n-1. In other words, we end at the second to the last, right? So those are the positions potentially it can trap water, right? So here the water trapped, let me just introduce an extra variable, right? So the water trapped actually is this, left I-1. So because here we are considering the current index, so left max would be this one. The reason we can use I-1 is due to the fact that we start from I from 1. And also write, we should write I plus 1, right? Then this smaller one minus the current height or elevation. This is the one. But this is not complete yet because the water cannot be negative. So what we do is max of this whole thing with respect to 0, right? And then you just need to add the water to the result. For sure, you can compact this two into one line, but let's write like this to make the logic clear. So now let's return the result. So now we can do a test. It passes the 2 test cases, right? So now let's submit for the generic case. Yeah, it passes all the cases. So here, let me make some comments. First, if you want to track each cell what's the amount of water trapped, you can do that. You can say print, so I and the water trapped. So that will be water, right? So then you can print out that. So here, this is the water. You have 1, you have 1, you have 2, you have 1, and then you have last one, right? This is the one. And for the second example, you can also see the water trapped is 2, 4, 1, 2. Adding them together is 9, right? So this is the one thing you want to notice. Another detail you need to notice is that the water should be greater than or equal to 0, not negative. So this is the max, offset max. So with that said, I guess that's the main coding part. So a suggestion is that try problem 11. So these two problems are similar, and also another one actually I specified in the previous video for problem 11. You can also try, right? So problem 11 can be solved using 2-pointer sliding window, right? You can try that. So if you found these videos helpful for your practice, you're welcome to sum up and share with your friends. With that said, that's the end for the current video. Thank you for watching.